my screen?
Yes. Yep.
Okay. Let me give a short introduction to the newly introduced raw format, as well as the just-in-time compilation introduced in DataFusion recently. First of all, I'd like to introduce the raw format, since we might be quite familiar with raw format, since we're all dealing with structured data in DataFusion. And also, the raw format will be a good use case for the just-in-time compilation, since it is only use case now currently in DataFusion repo that have already utilized in the just-in-time compilation. So the record representation we recently introduced is composed of 3 parts: the validity bit mask, one bit for each field, and the fixed wise fields. No matter your field is fixed wise by itself, like int or double or a float, or it is a variable length data like string or struct or something else. It will all first store in the fixed wise fields sequentially in this scope. And for the fixed size data, it will store as it is in this second part. And for the vanilla or variable length attributes, we will first store its length and offsets based on the starting offsets of the record. And therefore, if we have a schema of the record, we could quickly calculate each field's offset based on the schema. And for vanillas, we could first visit its fixed wise field according to the offsets, and using the starting offset and length to get the real content of that field. And yes, it is the record representation we have in DataFusion. The background why we need row representation in DataFusion is sometimes when we are dealing with a data set much bigger than the memory, we need to store data in memory sometimes, and we all know that CPU is best will access data by first loading memory data into cache and do calculation in cache and store that data back to memory. So when we are coping with very big data sets, bigger than the cache, the memory store problem would occur, since we may be accessing fields rapidly and irrationally. Especially there is a great showcase that is a hash table. When we store data in color formats, we organize table as a record base stored in a row in a color format. When we are accessing a record, we need to access different parts of the memory and load it to load it to cache to get a single cell. But if we organize data in row formats, one or two cache load would load all the record data into the cache, and we can fast access data, updating the fields, and write all these things back. That's that's the first use case I can imagine. Well, we introduce raw format or record formats in DataFusion, since we are not dealing with we are not all dealing with just input and output style processing. We may do caching, we may do hash mapping, we may sorting data. So the raw formats may play a role if we want to accelerate some of the operations. Yes, and besides, if we know the schema in advance, the validity bitmask might be omitted over all at once if we have no non-bits, non-fields in advance. Yes.
Yeah, and if I may just take a moment, like this row format type of thing that GJ is talking about is, I think, a very common way to improve the performance of a database system where the row, like basically you have to, the whole point of this, as GJ was saying, is not only does it improve cache locality when you've got a column store, it also avoids the, well, eventually we'll get to like avoiding the per type overhead, right? Like each one of these fields has like individual types. And so if you just do it naively, if you want to process data row by row, you've got to sort of switch on all the types. So I'm sorry, you should keep going, but like this is a great foundational piece.
Yes, yes. Just like Andrew said, when we are processing data in a row wise, like we update, like in hash table aggregation, we get a tuple in the hash table. We would like to update each of the aggregation buffers in the records. Then this time we could access each of the fields sequentially, update it, and then get the next tuple or aggregation buffer for the next incoming data. Yeah, that might be one of the use cases for the raw formats. And when we are dealing with this, we're always facing with very efficient processing. Is that when we are decomposing a record, we could have different schema for each of the field, and in order to access one of the field, we may write a branch of we may write a switch case or a branch, selecting the right code parse for decoding data or encoding data, and that's why just-in-time compilation always comes into play. That since each tuple or each relation is fixed with one schema, we could compose we could stitch or compose several functions together according to a record schema, and decomposing or composing, serializing or deserializing record using a just-in-time compiled function, and no further branching or other overheads included ever since. So that's why the raw format is introduced, and later the just-in-time compilation comes.
Yeah. So I also just wanted to reiterate what Izzy was saying, that in most of DataFusion and in column stores in particular, right, or arrow processing, since you store the data in columns, you basically can you implement vectorized computation or something. And so the overhead of like figuring out what the types are, you pay it once per like a million, like 1,000 rows or 10,000 rows or something. And then you can just run very efficiently through the remainder of the array. But there's certain operations in a database system that don't lend themselves to that kind of vectorized processing. Right? So stuff that does work great for vectorized processing is like filtering, projecting, running functions, right? Like all that stuff, very easy to just crank through, figure out what you want to do once, and then run through a big array. The operations that don't lend themselves well to vectorized processing like that are just what you said, hashing, right? Like when you got to when you're aggregating, you basically got to compute a hash for each one of the individual like logical rows and find where it belongs and put that somewhere. Sorting is another big one, right? Because you got to basically compare a single row by row. You can't compare giant swaths of rows together. You have to do it sort of one row at a time to figure out where they go. So sorting / merging is another place you can't really vectorize particularly well. And joins are basically the third one that I know, the third sort of canonical thing that you can't really vectorize that. You have to do it row by row to find whether they match or not. So, basically everywhere else in DataFusion, we play games with vectorized execution, but we can't do it for certain operations like this. Sorry, JJ.
Thanks, Andrew. Thanks, Andrew, for extending the view. So let's continue our introduction to the just-in-time compilation. The main focus of just-in-time compilation in DataFusion or in our structured data querying or execution is like to glue several kinds of methods. Each dealing with a specific data type together. If we are decomposing a row, we will need to stitch like decomposing integer, decomposing float, decomposing double fields into a bigger function, and we could avoid like branching depending on schema in the later use cases. And so we have the tiny or the cell functions based on the data type, and we will glue several of these basic functions into a giant or a bigger function that dealing with the records. And this is the first use case for the just-in-time compilation. The just-in-time compilation module in DataFusion is composed of several parts. First of all, the API that is used to constructing a function abstracts structured tree, and the AST part, just like we learn about the compilers or something else, we have the same things like in each computing language, the if else part, the while loop, the assignment, the core, and the declaration of the new variables. We need to compose a big function. And the GIT part, is based on the CreenLift library, and a short and the CreenLift as well as RVM are two alternatives while implementing the just-in-time compilation in DataFusion. But when I was facing with the two similar functionality parts, I think CreenLift is more lightweight, and we could when we are facing with just gluing tiny functions into a bigger one. Just in compilation with CoreLift might be enough. And also, if we further want to extend the ability to leverage like RVM capabilities, we could just substitute the JIT implementation with the that of the RVM's backend. Yes, and like programming language.
Did I hear you say that you chose to go with CoreLift because it was lighter weight?
Yeah. Yes.
But that
yes,
you designed the code so that we could switch in something like LLVM if we decide that's needed in the future.
Yes, we can switch to our LLVM backend in the future if we think CoreLift is not fast enough. Yes, we can just change the backend from CoreLift to LLVM. I think it's not. It will be a structure. It will be a restructure of the backend, but not touching the API or the AST for the program. Yes, I think it would be the lightweight, and it's.
What does CoreLift generate? Is it like literally doing code gen and then using Rust-C to compile, or is it like emitting like LLVM-IR or something?
Let me show the code parts, and I think it will be easy to follow. First of all,
yeah, I think CoreLift writes the instruction streams directly into memory is what I think it does.
Yes, it can manipulate structures in the memory, but currently I'm not using that. I'm not using that completely in DataFusion. I'm just stitching each of the tiny functions into a bigger one. Yes. The main entry point for the just in time compilation is the assembler. It's much like that of a. It's much like the programming language that have scoped variable and different variable names for the function. So there are two fields of the assembler states: the name for next ID in order to achieve to have occasionally creating of functions serially, but with different names. And the other is external functions. It is used to do type inference and do compilation time checking of the composed function before it's too late to report or panic at the runtime while we do function cloning or function composing. So for each external functions we want to glue into a bigger function, we have its function signatures, its name, the code pointer we will use later to call the real function. It's a pointer. We have parameters of the types for each of the arguments, and the return type if it has a return type, so it's optional. And the type we are using is based on CoreLift types that is supported. So when you are you've already construct you already register a function into the assembler, i.e. the main body or main entry points of our JIT. You could later use it like we do in the row composition or decomposition parts. Let me find a example for this. For example, we can you see the screen? We have the register function macro. It is indeed calling the register external function we've just seen. It's just like we are registering the record read field functions such as get array mute, read field boot, read field u8, like this tiny functions into the assembler as a state, and we'll use it later to read a record with a fixed schema out. And secondly, the assembler has the new function builder, and it is the entry point when we need to build a function for later use. The librs has a test case that use the basic function, the basic components like if else struct, while struct to construct a function. And I'll show like the record reader function, how the record reader function is constructed. We first register all the read function cells into the assembler. Then we generate row, and since we have the schema ahead of time, so each time we get a cell from the array, so we have the get array mute as a variable, new variable. Then we can read field boot or read field int from the array according to the array type. And then if we already know that the field is not nullable, we could directly read the field boot now free to avoid further branchings here. And once we have stated all the cell functions according to the schema, we call the build on the code block, and finally get the generated function we've just constructed accordingly using the if else branch, the while branch block, and we got the generated function. Once we got the generated function, we can pass it to the JIT to assemble to generate to get a function pointer of the generated function. Yes, it's here. And this is in the JIT RS, the compile function from the assembler. It has all the scopes information, the register functions, and it's time to using Crane lift to compile the AST we've just constructing into a runnable function. It's the compile works for. It will declare functions, and it will do some context cleaning and seal the function at last, and we'll finally get a JIT constructed code, so we can use it later. So it's when we'll need it only one time, we can just compile it and we can transmute it. Of course, it's unsafe. Transmute it to like a function, like a normal function, and call the function with its input data. Yeah, it's a simple path if we want to only compile the code once and compile it once and call it once. And also for the reader part, we have the other parts. That is often the use case, that is we compile it once, we construct the AST once, compile it once, and use it repeatedly for all the records in a batch, like for all records in a batch, and do branchless computation, and finally get the result of the function or everything else. Yes.
So Jose, is it fair to say that like what you've just shown us is basically the ability to, given a schema, compile a specialized function that will copy data out of record batches into the row format, and then likewise will copy from the row format into record batches?
Yes.
But so we could write, we have versions of that function already today in the DataFusion code base, but the difference of using this JIT is right now the code in the current DataFusion code base will, for every row that you want to do that conversion, it will basically walk through and say, you know, what's the next field's type, and then switch and do whatever it needs to do, and then it always has to iterate over and do that branching, like checking and switching on what the fields types were. Whereas I think the power of what you just showed us is that the decision of what schema, like what types exist, gets done once. Then you have a function that doesn't check types for every row. It just runs whatever the pre-computed function is. So you basically save a huge amount of overhead per row.
Yes. So once we have generated the function, we in the type loop we can avoid branching and do all the calculations. And also, since we've registered external functions with parameters and its return types, we can also declare. Sorry, can you see this? We can declare data of different types. Here we have basic structure like all programming language. We have literals, we have identifiers with just with queen-lift types or abstract type with parts. So while you are constructing the function, you will, and when you compile it, you will get early compiler complaints when you are using the type wrongly. Since when we are structuring the generated function, we already passing the type along, so we can do type inference, and we also have the scoped variables, like the inner scope will shadow the outer scopes variable of the same name, and it also has the ability to do this. So the just-in-time completion is just like writing code snips composing of several atomic operations using AST or using a DataFusion API to compose the function and call the function repeatedly hereafter. Yeah.
Yeah, cool. Well, like one thing I'm interested in using this for is speeding up the speed of like sorting and comparisons. Maybe I'll talk about that some other time, but I think you can use this to build a specialized, like, copy data from record batches into a row format that will then you can compare very quickly. So I'm super excited about this. It's gonna be great. And I think, GJ, the plan is like for every operation we have, we'll have like the dynamic dispatch version, right? That doesn't require the JIT, that'll just check each field. And then we'll also, hopefully over time, add in the JITted version of it.
Yes.
Yeah,
Yes, we do.
That's gonna be cool.
And we have the read as batch JIT version, as well as the dynamic patching version like this. For record, for reading row from a record batch, we have the branching for each record in the batch. So it's like for each record, each cell, we need to get its data type, and branching based on the data type, get the cell functions. So it is not a problem while we are doing vectorized computation, since we are branching at like 1,000 lines a time. But when it comes to record processing or volcano style processing, we will branching each field or each cell, and the branching overhead or the breaking of the CPU pipeline is neglectable. So it's where JIT really shows. Yes.
It's very cool. Thank you very much.
So I'm assuming that bugs in the JIT here could also introduce runtime memory bugs, right? This is
Yes.
okay.
Yes.
Yeah, this is about as unsafe as it gets, I think. But I think that's why it's sort of would be important to have two, like always have the two code paths, like one that's super safe, everything's checked, it doesn't require JITs, nothing, right? Then we got the JIT version. You can always switch back to the non-JIT to see if there's any, you can always switch back if you're seeing problems and try to isolate it.
Is I don't know if this is sort of decided or but I guess is the idea that you would sort of JIT functions optimistically, or is it more of a heuristic based, you're only going to JIT hot functions based off runtime statistics?
The choosing of whether JIT or not is not settled down currently. I think the JITs we would like to introduce JIT only for the hot functions. We see in like TPCS or TPCH, like composing records for decompose free comparison or something like this, only at the hot code parse, of course.
Yeah, and I think it's like there's a few places in DataFusion that the hot path, there's really no, that we basically got, they're optimized as much as they can be without a JIT or something like this. So the paths that I know of are like when you're doing group by hash, right? The actual manipulation of the multi-column group key, and then the multi-column aggregates. Right now, those are all, basically, vex of scalar values or something. So you've always got to be doing this type dispatch, and that's in the inner loop. And so there's basically no way to make group by hash faster. I shouldn't say no way, but like there's no obvious way. We spent a bunch of time trying to make that faster without sort of getting rid of the branch overhead, because that's now hot. Likewise, when we're doing like multi-way merges of different record batches, which happens in the external sort that GJ also wrote, like the the merge is like a fundamentally single-threaded operation, and you basically have to be like doing multi-column comparisons. And that's also basically like the hot path, and it's not really bottlenecked on the dispatch, but the dispatch is a non-trivial amount of time. So to get that faster, we need to get rid of the dispatch overhead.
Okay. And would it be possible, like even in principle, to push this up to compile time or build time, to basically say I want to, it wouldn't be a JIT at that point, it would just be, but I want to generate the optimized version of this function. If you have, for something like a scalar function where you have, I guess the input and output schema.
The input and output types. Yeah, I think you could in theory JIT scalar functions. My suspicion is maybe, sorry, go ahead.
Go ahead.
I was just going to say, I think most overhead of like scalar function type dispatch is, you can get around it by vectorized processing, right? Because you're not switching on the type per row, you're switching on the type per input array, input batch. So you do it once and then process 1,000 rows or whatever. It's, whereas when you're doing group by or these merges, you can't process multiple rows at once because of what the algorithm is doing. So that's where I think this JIT will really shine.
Cool.
It's very cool stuff. And unfortunately, I don't think you can pre-compile the grouping code or the sort comparison code because it's a function of the schema, right? So you don't know the schema a priori. You need to, it's a function of whatever the query is.
Right.
What columns are being grouped or whatever.
Probably once for each query, and the compilation time should be quite slow. But since it's only occurs once for each query, I think it's acceptable comparing to the benefits it brings. Yes.
I think that's another potential benefit of crane lift over something like LLVM, that the compile time I think is quite a bit lower because it doesn't have all sorts of fanciness that LLVM does. But that's okay for these simple functions.
Yes, at this time, I just want to glue for several functions into a bigger one. So I think crane lift is enough. If we are thinking of like the LLVM fancy ability to compile several functions together and get a a further reduction of the code and the reduction of the code parse, I think it's when we should consider LLVM that time. Yes. Do we have any other questions on the JIT or the row format?
I have one question about the row format.
Yeah.
Oh, first of all, thanks. This is really cool stuff, and I also see a huge benefit also for the sorting kernels. So the current lexicographical comparator also either has to do type dispatch or dynamic dispatch, and it needs to know whether it's ascending, descending, nulls first, last, and so on. So generating code for that would also be really cool. But regarding the row format, I'm wondering whether this row format could be compared directly as a byte array.
Yes.
Especially the variable lengths data, which is at the end of the.
It can be compared for equality.
For equality, yeah, I was thinking about lexicographical comparison. If you have a tuple that contains integers and strings, if I can say, okay, this one row should be sorted before the other row, or if I for that have to generate more specific code or know the schema again.
For the time for now, we can only compare two records if of equality, as Andrew said, and yes, it's we can only compare for equality, but we can have the ability to do lexical sort if we do different encoding and padding of the records while constructing. For example, for variable length data like string, you should, when you want to compare two records, two records with different string, you need to pad the shorter one as long as the longer one, and assure that the shorter one in byte representation, or we compare the records by bits. It appears before the longer one. Maybe padding the shorter ones with leading zeros before in the front, and for the variable length fields, and for the IEEE encoded float or double, you will need another strategy to you will need another strategy to encode the data. You will need to encode the data that is comparable, since IEEE float or double is composed of two parts. So there is already an algorithm for encoding that field to be comparable and decoding that when you have done with the comparison. Yes, it's possible when we have the ability to like padding records and padding null bit sets, and like the ability to directly do lexical sort based on the radic sort functionalities in the future, I think.
Yeah.
Cool, thanks.
But I don't think you can use this format as it's written here.
directly. I realized while asking the question about ascending, descending is a problem, but I guess you could generate code for a comparator.
Yes.
And that would avoid all the type dispatch. Yeah, so that would already be a big win, I guess.
Yes, if we have the byte sortable representation, we only have to encode the data into the byte array and do just a radix comparison. No need to decompose it during the comparing. This is the main point.
Yeah, there's a great paper like from Guts Graph maybe 20 years ago that sort of just enumerates, like it basically talks through all the different strategies and the trade-offs. So yeah, it'll be cool. All right, nice.
How much is the speed up? I just checked, there is actually a benchmark, but I haven't run it yet.
I think for the row decomposing row record from record batch, it's about 15% speed up for about several million records.
Well, but it's also it's going to depend too on how many columns are in the input data, right? You can basically make it, you can probably make it as fast.
Yes.
You can make it as much faster as you want by just making the input wider and wider, because you're going to keep paying that dispatch overhead.
Yes.
Yeah. But yeah, I think this will really shine if GJ gets it stuck into group by hash. I think that'll be like that'll have some major wins.
Yes, I'm planning to do group by hash using with the row representation as well as the JIT if possible. Any further questions?
Thank you so much, EJ. This is great.
Yeah, this is really cool.
Thank you.
Everyone.
Yeah. Have a good night. Thanks for staying up, EJ.
Yeah.
Late there.
Good day. See you, everyone.
Thanks.